created by MindSticks Foundation Trust. Welcome to today's Explainer, students. We're going on a bit of a masterclass journey today to deeply understand quadratic equations layer by layer. We will be looking at 4 key areas: visualizing solutions, the quadratic formula, the power of the discriminant, and finally, how roots and coefficients are connected. Let us get started. Section 1. Visualizing solutions, seeing the roots. Now, before we jump into doing any manual calculations, let us just take a moment to see what a solution actually looks like on a graph. Observe carefully how the U-shaped parabola, that is our y equals x squared, and the straight line for y equals 2x plus 3 intersect. If you look closely at the grid there, you will notice they meet exactly at the coordinates -1, 1, and 3, 9. So here is the golden rule you must remember. The x-coordinates of these exact intersection points, -1 and 3, are the actual roots of our quadratic equation. Seeing this connection really bridges the gap between geometry and algebra beautifully, doesn't it? Moving to Section 2, the quadratic formula, the universal tool. Right, so now that we have that visual intuition of what a root actually is, let us bring in our most reliable, everyday algebraic tool. Behold the almighty quadratic formula. This right here is your master key. X equals minus b plus or minus the square root of b squared minus 4ac, the whole divided by 2a. And the beauty of this? It works universally for literally any quadratic equation in the standard form. Notice the clear sequence in this logical flowchart from our textbook. It is guiding us step by step from simply comparing equations all the way down to substituting our values. It is a very systematic approach. To avoid those silly mistakes in your exams, always follow these 3 methodical steps when you use the formula. First, compare your given equation with standard form, ax squared plus bx plus c equals 0. Second, carefully extract your values for a, b, and c, and please pay close attention to their signs. And third, substitute them into the formula and solve. But wait, here is a really fascinating twist. What happens if the number inside that square root symbol becomes negative? I want you to really think about this for a second, because this specific question, it leads us directly to the hidden DNA of these equations. Section 3, the power of the discriminant. Unlocking the hidden DNA. Let us zoom right into that specific, powerful part of our formula to answer that very question. The expression b squared minus 4ac is called the discriminant. We denote it by the Greek letter delta, which looks like a small triangle. You see, this single piece of the formula acts almost like a crystal ball. By simply calculating this delta, we can predict the exact nature of the roots using just 3 simple rules. First, if delta is greater than 0, the roots are real and unequal. Second, if delta is exactly 0, the roots are real and equal. And third, if delta is less than 0, meaning we have a negative number sitting under our square root, the roots are simply not real numbers. Let us see this in action. Take a look at example 4, where calculating b squared minus 4ac gives us exactly 0. This perfectly results in our roots being identical. Both are minus 3 by 5. Now look at example 5. Here, our delta becomes a negative 19. Because the square root of minus 19 is not a real number, we can immediately declare that the roots are not real and stop right there. These solved examples really illustrate how quickly we can find out if roots are real or not, without having to laboriously solve the entire equation. Just identifying a, b, and c and finding delta saves us so much precious time and effort. Finally, Section 4, Roots and Coefficients Connected, the secret relationships. Let us explore the elegant algebraic connections between the roots themselves and the coefficients a, b, and c. Let us call our 2 distinct roots alpha and beta. Notice how beautifully adding and multiplying the 2 parts of the quadratic formula simplifies things. The complex square roots literally cancel each other out during addition, leaving us with a very neat result. Please make a note of this incredibly important formula. The sum of the roots, alpha plus beta, is simply negative b divided by a. And the product of the roots, alpha multiplied by beta, is equally simple. It is just c divided by a. Now, why does all of this actually matter? Observe example 3 carefully. Even without knowing the individual values of alpha and beta, knowing just their sum and their product allows us to calculate highly complex expressions like alpha cubed plus beta cubed with absolute ease. We just use standard algebraic expansion formulas, substitute minus b by a and c by a, and the answer simply appears. Understanding these secret relationships is the real game changer. It is what elevates you from just calculating to achieving true algebraic mastery. Mastering these connections helps us skip those incredibly long manual calculations, find unknown variables like k effortlessly, and evaluate expressions that initially look quite intimidating. Before we wrap up this explainer, I want to leave you with a very interesting puzzle to think about. If you were only given the sum and the product of the roots, can you somehow build the original quadratic equation backwards? Think about how a, b, and c relate to those given values. Until our next session, keep practicing, keep asking good questions, and keep exploring the wonderful logic of mathematics. Thank you so much for joining me.